I'm looking at the Idaho batholith, which is basically a huge blob of granite that now is exposed in most of central Idaho. This was granite that was magma between about 90 million years ago and about 55 million years ago. So this is a long-lasting episode of magmatism where there was all of this molten liquid rock beneath the surface that has since solidified and is now exposed at the surface. In my project, we're using this tablet computer which has a GPS app as well as our handheld GPS to track our sample locations all over Idaho. So this little blue arrow shows us, and this star would be the site where we are currently. These sites that we're collecting from were visited by another geologist working in this area, Rich Gashnig at Washington State University. He collected samples and did geochronology to date all of these sample sites to figure out how old the rocks are in each of these places. The dates Rich Gashnig found represent the time that the magma crystallized into a rock. The alignment that we see in the rocks also formed at that time, so relating the alignment that I measure to the date of the rock that Rich Gashnig found gives us an idea of the patterns and fabrics within the rock and when they formed in geologic time. We were looking at the rocks in the outcrop and taking observations about what the texture of the rock looks like. We're looking for evidence of deformation in these rocks, some preferred alignment of the minerals into a planar or linear feature that we call fabric. Sometimes in outcrop you can see this alignment, you can measure the alignment and figure out how the planes are oriented. You see anything?
Nope, it looks pretty even.
We're not really seeing any alignment of these minerals within the rocks. There's not really any fabric to be measured, so we have to collect the sample and take it back to the lab and use more analytical techniques that will help determine the orientation of minerals within the rock. The whole goal is looking for that fabric, whether we can do it macroscopically in the outcrop or with techniques in the lab, and ideally both. We're looking for a sample that is the right size to do everything we need to do to it. It has to be in place in the outcrop. We can't just pick something up off the ground, and we're looking for something ideally that already has some fracture that it will be easy to separate from the outcrop. We don't just have to chisel away at a huge mass of rock. We're drawing orientation marks on this rock so that we can reorient it in the lab the way it was geographically in the outcrop. So first is a horizontal line, and then a couple lines so I know which way is down, and one so I know which way is up. And we need to do that on multiple sides of the rock. The next step is to get the rock out of the outcrop so we can take it back to the lab. We're using the GPS to record the latitude and longitude for the sampling site so we know where this sample came from so we can plot the data on a map later. Now I'm using this instrument to determine the magnetic susceptibility of the rock, which gives us an idea of the mineralogy. The instrument records the magnetic response of the rock to an applied magnetic field, which gives us an idea of the properties of the minerals within the rock, telling us whether there are minerals with high iron content present or not, which will be important later in the lab when we do the analysis. This is data that we'll get in the lab as well, but it's a good idea to have the measurement in the field too, so we sort of know as we're going along the properties of the rock that we're working in. I'm writing the sample name on this rock so I remember exactly where it came from. To proceed with that lab work, we have to reorient the sample as it was in the field. So the lines that we drew on it to mark horizontal and north will be used to reorient the sample. We'll place it in a bucket of sand to reorient it the way it was in space, so it's exactly the same way as it was in the outcrop that we got it out of. Since we're looking at the geometry of the minerals, we need to care about what that geometry was like in the outcrop, so we have to try to reorient it to that same place.